Welcome to the Explainer. Today, we're tearing down something you probably wrestle with every single day, maybe without even realizing just how much it's dragging you down. We're talking about the hidden costs of traditional full-stack development, that dreaded full-stack tax. More importantly, we're going to dive into how schema-driven automation is stepping in to solve it, completely transforming developers from manual, line-by-line coders into highly efficient systems architects. Let's get right into it.
Here is the roadmap for our briefing today. 1. The full stack talks. 2. Anatomy of API drift. 3. Schema-driven automation. 4. Real-time feedback loops. And 5. The systems architect. All right, kicking things off with Section 1, the full stack tax, our traditional paradigm. Think about your standard decoupled architecture. You know the drill. Pairing a high-performance Python backend, maybe managing your data with fast API, with an enterprise React frontend. In this traditional manual setup, you are instantly hit with a hidden performance tax, and it's brutal. We're talking about a staggering 30% hit to your momentum. You're losing almost a third of your day doing nothing but hunting down missing property fields, fixing tiny syntax discrepancies, and just typing out endless boilerplate serialization logic across your repositories. It is a massive drain on productivity. So why is this happening? Well, it all stems from the heavy burden of executing 4 totally disconnected manual steps just to get a single new data feature out the door. First, you've got your backend schema definition, manually writing out those Python data structures. Then, step 2 is endpoint configuration, where you're explicitly coding the routes and serialization. Step 3, front-end state mapping, that's writing out your async fetch operations over in React. And finally, type alignment, where you have to declare manual TypeScript interfaces just to keep everything from falling apart. It's 4 isolated, incredibly time-consuming steps. Which brings us to Section 2, the anatomy of API drift, the ultimate momentum killer. That brittle 4-step coding loop we just talked about leads straight into our biggest, most expensive headache, API drift. Basically, API drift happens when a tiny, seemingly innocent structural change on the back end unexpectedly breaks the entire application runtime on the front end. It turns what should be basic interface synchronization into this constant, frustrating hunt for mismatched data types across your stack. You tweak one tiny pydantic model attribute, and boom, your React component completely crashes. We've all been there, right? Enter Section 3, Schema-Driven Automation, powered by the AI Agent Loop. Thankfully, there's a massive paradigm shift happening right now that effectively kills this API bridge as we know it. And it's all thanks to schema-driven automation. By leveraging advanced multi-file AI agents and deep repository indexing, we can completely flip our perspective. We stop treating front-end and back-end code like they're living in isolated silos. Instead, the agent sees the entire repository as one single, cohesive graph of logical inputs and outputs. The AI actually has full structural awareness of both your client and your server directories at the same time. So, what does this actually look like when you sit down to work? Instead of writing out data pathways line by painstaking line, you define a unified data contract. You literally just pass a high-level logical prompt to the agent composer. You can tell it, implement a secure payload pathway that ingests raw imagery on a fast API route, processes the tensor array, and updates the local React dashboard state. You're dictating the system architecture, and the agent takes care of the execution. This perfectly highlights the core difference. It's the old manual way, let's call that the typer, versus this new agentic orchestration, the architect. Because the AI knows exactly what's going on in both directories simultaneously, it performs multi-file synthesis. It instantly writes the pydantic schema on the backend, and in the exact same breath, generates the corresponding React state updates and TypeScript types on the front end. The whole chore of bridging the stack is automated in literally milliseconds. Moving right along to Section 4, real-time feedback loops and eliminating compilation friction. The secret sauce making this agentic workflow so unbelievably fast isn't just the code generation itself. It's the proactive bug mitigation. Think about the standard pipeline timeline for a second. Error detection is just painfully reactive. Minute 1, you compile the server. Minute 2, spin up localhost. Minute 5, you trigger a user event. And then finally, at minute 15, you're inspecting the browser console just to find one broken data field. You're forced to slowly walk through that exact same agonizing timeline over and over again. But modern AI agents flip the script by using an active local compiler feedback loop. If the agent modifies a Python model that changes a property React is expecting, it doesn't just wait around for a crash.
The integrated environment actually captures localized linter warnings within 100 milliseconds, and it runs an automated code patch before you ever even trigger a manual local build. We are talking about completely crushing a 15 to 30-minute manual debugging loop down to less than 400 milliseconds. That is just a staggering leap in efficiency.
And that brings us to our final section, Part 5, the Systems Architect, the new directive. So what does this massive leap in speed and accuracy actually mean for your daily engineering workflow? Well, looking at the hard architectural metrics collected across standard interface rollouts, the data proves the absolute dominance of this new workflow. Feature scaffold time drops from 2 hours, or sometimes a full day, down to less than 5 minutes. The API drift error rate plummets from incredibly high to literally 0% because schema validation is totally synchronous. And boilerplate generation shifts from manual line-by-line typing to being 100% automated through LLM reasoning. The directive for modern developers is crystal clear, and it really just leaves us with one critical question. Are you going to keep wasting hours acting as the typer, building out basic API bridges, and mapping network requests by hand? Or are you ready to offload all that interface boilerplate to intelligent agent loops and officially step into the role of the systems architect? Because right now, it's time to stop fighting minor syntax discrepancies and start focusing all of your creative engineering firepower on core business logic, scalability, and robust system architecture. Thanks for hanging out with me for this explainer, and I truly hope this completely changes how you look at your very next deployment.